All right, here's number 17. This is, of course, talking about the end of the dinosaurs. 66 million years ago, an object which was very likely an asteroid hit the Earth, traveling at about um, 20 kilometers per second. All right, we'll get to that a little bit later. It had an estimated diameter of 10 kilometers and was composed of rock and metal with a density of about, let's say, 4 grams per cubic centimeter. What would be the mass in kilograms of this? And we're going to express our answer in scientific notation, rounding one place past the decimal. And then part B, which it doesn't say that, but this is part B. How many millions of megatons of TNT um, uh, of kinetic energy would this be? 1 megaton of TNT is the equivalent to 4 times 10 to the 15th joules. All right, so there's our two answers. So part A, we're going to get 2.1 times 10 to the 15th kilograms, and then part B, it's going to be 105 million megatons. All right, so that let's work this out. All right, well, first thing we have to do is we take this object. If it had a diameter of 10 kilometers, the radius, we of course have to divide that by 2, and then let's convert it into centimeters. Remember, 1 kilometer is 10 to the fifth. That's supposed to be a 10 to the fifth centimeters. All right, so here we go. Let's get our calculator ready to go here. Clear it. All right, so here we go. So 5 times 10 to the fifth. All right, so that's the radius of this thing. Okay, so there. Yeah, I don't know why I just did that. Here, let me make sure. Let me completely clear it. I thought I had. So 5 times 10 to the fifth. All right, so that's all right. There we go. All right, so that's the radius, and we're going to need the volume, and so the volume, of course, of anything that's spherical is 4 times pi divided by 3 times the radius to the third power. Of course, the radius has to be um, in centimeters. All right, so I've already got that number. It's right here in my calculator. That's what I just calculated. All right, so I'm going to cube that and then multiply it times 4 times pi and then divide it by 3. All right, so this is my volume, very large number indeed. All right, so I'm going to store that. All right, so let's see. This is going to be roughly 5.24. All right, so I'll figure out how many decimals this is. So 5.24. If I round it there. Now I'm going to leave it unrounded just to actually do the calculation. Let's see. So the decimal is right here between the 3 and the 0. So let's see how many decimals is that. So it's 1, 2, 3. There's 6. There's 12, 15, 16, 17. So 5.24 times 10 E17. All right, centimeters cubed. All right, so now you kind of got to stick with this. All right, so the density, which they give us, the density is 4 grams per cubic centimeter, and that's equal to the mass divided by the volume. Now we just figured out what the volume is, right? That I stored that in my calculator. So if I just take the mass, or if I solve for the mass is 4 times the volume, right? Well, the reason it's 4 is because they gave us 4 grams per cubic centimeter. All right, so we just multiply this number by 4, and we will get the mass. Now, but that's the mass in grams. Okay, so here, so if I multiply this times 4, all right, so there it is. All right. You notice that there's where you get the 2.1, right? So we know the answer is going to be 2.1 times 10 to the 15th. Now, all right. Here. So this number. Let's see. I got to figure this out. This number is there's 6. There's 12. There's 15, and there's okay. So it's going to be 2.1 times 10 to the. Oh, geez, I already lost count. So there's 6, 12, 15, and then 18. Okay, so 2.1 times 10 to the 18th. 2.1 E18 of grams, right? And so I know, I just got to rewrite this, 2.1 E18 grams. I know that in 1 gram, there's 1,000 grams in 1 kilogram, all right? Because I need this to be in kilograms. That's a K. So the grams cancel. And so if you divide this number by 1,000, it turns into here. So let me just show you this. So if I divide it by 1,000, there it is. All right, and so now this number becomes 2.1 times 10 to the, well, let's figure it out. Okay, so the decimal's right here. 1, 2, 3, so there's 6, there's 12 times 10 to the 15th. All right, so 2.1 times 10 to the 15th. 2.1 E15 kilograms. All right, that's quite a bit just to get that. All right, so that's part A, and that's we already knew that was the answer because I had worked this out a long time ago. All right, so for part B here, so how can we figure out part B? So for part B, they want us to well, let me do one more thing as well. The velocity. Notice the velocity is right there, 20 meters per second. So the velocity has to be, 20 kilometers per second. That has to be in meters per second. So that's really 20,000 meters per second, right? Because 1 kilometer is 1,000 meters. All right, so now we're ready to do the kinetic energy. So the kinetic energy is going to be 1/2 the mass, which is this number here, 2.1 times 10 to the 15th, which is already in my calculator, times the velocity, which is 20,000, and you got to square that. All right, so that's going to give us an answer in joules. All right, so here since I already have the mass. All right, so there's the mass. Actually, let me store that just to be on the safe side. So I'm going to store that. I'm going to divide it by 2 because that's what you have to do. And then so that's what that is. And then times 20,000. 1, 2, 3, and I've got to square that. All right. So so that number right there is the energy, is the kinetic energy in joules. All right, so we'll figure out what that is. Looks like, what do I want to round this to? Round one place past the decimal. So it looks like 4.2. All right, in joules anyway. 4.188 times 10 to the, well, we got to figure that out in just a second. All right, so 4 point, I'm gonna say 4.19 just to make our lives simpler. 4.19 times 10 to the what? Well, we got to figure that out. So, and that's just counting the decimals. All right, so there's 6 of them. There's another 6. So I'm up to 12, 15, 18, 21, and then 21, 22, 23. So 4.19 times 10 to the 23rd joules. All right. So, and then, of course, we know the fact, they give us this in the problem, that 1 megaton of TNT, all right, so 1 megaton, all right, of TNT, I'm not going to write all that, is the equivalent of 4 times 10 to the 15th joules. All right, so the joules cancel, and so you just take that number that's in the calculator already. All right, let me get to that. Where is it? There it is. All right, you take this number that's already in the calculator, and we're going to divide it by 4 times 10 to the 15th. All right, that's the number of megatons of TNT. That's what 1 joule is. That's what 1 megaton is. That many joules. All right, so this turns out to be so it would be one point. So it says, I think in the second one we get it rounded to 2 places past the decimal. So it's 1 point. Well, if we look at it right here, right there's the decimal. So if I go, there's 3, there's 6, so 104.7 million, right? 104.7 million, or another way of saying that. So here, so let me just write that. So that would be 104.7 million, or megatons. Mega. I could write out the word now. Tons of TNT. All right, this is like a nuclear bomb going off, just to let you know. Actually, there's never been a nuclear bomb of 104. I think the largest one ever built was like 50 megatons. But that's a substantial. That would be a substantial impact. And really, this is what killed off the dinosaurs, right? This was so much energy that this impact, which actually turns out we know where it happened. It was just off the coast of what we call nowadays the Yucatan Peninsula, near Mexico, and there's still a crater underneath the ocean, or in the ocean floor, and if that's how we can estimate the size of this thing. And so this created about 105 megaton explosion that affected the whole world. I mean, there was this giant dust cloud that covered the Earth for perhaps even several decades, many decades, and so lots of vegetation died out. Of course, lots of the larger all the dinosaurs died out. Most animals, if they were more than if they weighed more than 10 pounds, they didn't have enough to eat, and when those decades of darkness, not complete darkness, but a lot of darkness, they just that's when the dinosaurs ended, and then after that was the age of mammals. All right, so that's problem number 17.